All right, question 27. Let's do this. So we want the acceleration and we want to relate it to the speed. Let's get the acceleration. Let's derivatize this. That's going to be negative beta v naught e to the negative beta t. But oh my goodness, that's just v. So a, sorry, I shouldn't put a dot there. A is negative beta v. Whoa, who knew? All right. Here's a force. We want to know its compression, its energy when it's been compressed to distance x naught. Oh my goodness, kx cubed over 3. Just like that. And then we put in from 0 to x naught. That's going to give us kx naught cubed over 3. Don't even think about it. Just do it. Work is f dx. Do the integral. That'll tell you the potential energy as well. All right, here. So this is what we call the small angle approximation. And they'll throw in a bunch of weird, confusing things to tell you right now. If you want to really mess up a pendulum measurement, what you do is you release it from horizontal. Okay. E. Now, a person goes to the bottom of a mine. What actually happens? It actually turns out that as you approach the center of the Earth, you get more and more close to weightless. So it actually turns out that your weight is less than it is at the surface the further down you go. Isn't that crazy? Isn't that amazing? No? Okay. All right. Let's just finish up this whole little AP exam. So we want to know r in terms of omega, the angular velocity. Let's be clear on something. So v over r is omega, and for a planet we've got 2 pi r over t is v. So if we're going to get omega, let's just divide by r. So that means 2 pi over t is omega. So now keeping this in mind, gmm over r squared equals m v squared over r. Let me just do one thing. Let me multiply top and bottom by r, like this. So I added an extra r there. And, oh, that's terrible. There. So let's multiply top and bottom by r here. And now what's going to happen is I'll be able to simplify. I'm going to cancel these m's. So I'm going to get gm over r squared equals m omega squared times r. Let's multiply both sides by r and divide by m omega squared. That's going to give us e as our answer when we actually simplify. All right, now here, the blocks start at rest. And just so you know, the center mass is somewhere between blocks, and it never moves in momentum problems, just so you know. And then for 33, let's get the force. Let's get that average force. So F equals m delta V over delta T. That's going to be 0.06. Careful, we go 0.06, and let's be really careful. We go out at 10, but we came in at 15. And that's all over 0.03. So that's going to be 2 times 25, which gives us 50 newtons worth of force. Now, how does the magnitude of the average force exerted by the ball and the racket compare to the force of the racket and the ball? Total third law question, B. And finally, question number 35. So this is an angular momentum conservation question. So let's just kind of, we haven't done too many of these, but we're going to practice this week. So we've got mvr, that's the angular momentum of this dude. So you take the momentum and times it by the radius. And then here we have an angular momentum of I times omega. And what's going to happen is that they're going to hit and stick. So I've got I plus mr squared. I take their total I times the omega total. And so to isolate omega total, which is what they want us to do, that's going to be mvr, mvr plus I omega original over I plus mr squared. Are there any choices that look like that one? Why, yes, there are. Choice C. So that wraps up our multiple choice section. And we'll take a look at the free response in the next set of videos.